Hello everyone, welcome to Pay1 Tech Media. This video is a recap of IPv4 default subnet mask. Let's jump into my computer and have a look. So as we previously talked about the default IPv4 subnet mask address structure, that anytime when we talk about IPv4 is a combination of IP address and subnet mask. And we talked about that how in IPv4 there are 32 bits. So as we can see here, all the 32 bits, there are 4 octets. This is the first octet, second octet, third octet, and the fourth octet. And in every octet, we have 8 bits. So these are all the 8 bits, 1, 2, 3, 4, 5, 6, 7, 8. So this is just the placeholders for all the 32 bits. Now when we look at default IPv4 subnet mask, same thing, we do have 32 bits, as we can see here, 4 octets, every octet, 8 bits. So this is the first octet, second octet, the third octet, and the fourth octet. The decimal values of every octet depending on how many bits it's being turned on or being turned off, which in binary number system, 1 means on, 0 means off. And as we previously talked about in IPv4, there are 5 different classes: class A, class B, class C, class D, and class E, which mainly we do have subnet mask for class A, class B, and class C, because class D it's mainly used for multicast communication purposes, and class E mainly used for scientific and research purposes. Therefore, we don't see subnet mask for class D and class E. So here we can see the structure of default IPv4 subnet mask for class A, B, and C. So if we take a look at class A, for example, we can see the first octet, all the 8 bits are turned on. So here, as we can see in class A, the first octet, all the 8 bits turned on. So anytime when we turn on all the 8 bits here, for example, let's say if this is for class A, so 1, 2, 3, 4, 5, 6, 7, 8, all the 8 bits turned on. These ones represent the network bits and zeros represent for the host bits. And of course, anytime in any octet when we see all the 8 bits being turned on, the decimal value is 255. So where they're coming from, here we can see in binary number system, we talked about they have a bit position, which we can see the bit position here, 0, 1, 2, 3, 4, 5, 6, 7. Exactly same thing for the second octet. Each bit position, as we can see here, 0, 1, 2, and so on. Same thing for the third octet, and same thing for the fourth octet. Now why the base is 2? Because of the binary number systems. We have only ones and zeros. So base to the power of bit position gives us a decimal value. So these numbers to the top, these are the decimal values. In previous videos, we talked about how we can convert binary to a decimal. This is one quick overview. So if we have all the 8 bits turned on, so basically we just need to add the decimal values that's being turned on. For example, in class A default subnet mask, the first octet all being turned on. So all the ones representing on, we just need to add the decimal values of the ones that it's being turned on. In this case, default subnet mask class A, first octet, all the 8 bits turned on. So when we add all the decimal values, it gives us 255 on a first octet. So this section here is the binary notation of default subnet mask. This section here is a decimal notation of default subnet mask for class A. And this section here is the prefix notation of default subnet mask for class A. So default subnet mask for class A, we have 8 bits, network bits, and 24 bits for the host, which gives us a decimal notation of 255.0.0.0. and the prefix notation of 8. This 8 means we have only 8 bits turned on, going from left to right. Now if we take a look at class B default subnet mask, in class B default subnet mask we have 16 bits for the network and 16 bits for the host, which when we convert this binary to decimal, it gives us 255.255.0.0, and the prefix notation would be /16. And again, this /16 means that 16 network bits. Again, going from left to right. Now let's take a look for Class C default subnet mask. For Class C default subnet mask, we have 24 bits for network bits. Again, ones represents the network bits and zeros represents the host bits. So how many host bits do we have? For default subnet mask Class C, we have only 8 host bits. If we count 1, 2, 3, 4, 5, 6, 7, 8. As we talked about earlier, every octet we have 8 bits. So remember, default subnet mask Class C is 255.255.255.0. And again, where this 255 is coming from, when we convert these 8 bits on the first octet to the decimal, here the first octet, all the 8 bits turned on, it gives us 255. The second octet, all the bits turned on, these are the binary numbers, since all of them being turned on. So when we add 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, it gives us 255 decimal value. So this is an example of converting this binary number to a decimal number. Now on a third octet, exactly same thing. We have 8 bits all turned on. So when we convert this binary to a decimal, we just need to add all the decimal values to the top, right? So when we add all the values on a third octet, so this is the third octet, these are the decimal values, again where they're coming from, base 2, right, to the power of bit position. Why 2? Because of the binary number systems, zeros and ones. Okay, so on Class C, the third octet, also we have all the bits turned on, so the decimal value is 255. On the fourth octet, all 0, so we have decimal value of 0. Therefore, default subnet mask Class C gives us 255.255.255.0, and the prefix notation or the CIDR notation is /24. 24 network bits. Now, what does this mean? By looking at default subnet mask, we can tell how many bits we have for the network and how many bits we have for the host. So for example, if I ask you a question, on which class we have the most available host bits? Very good, in Class A. So zeros represents the host bits, right? Therefore, in Class A, we will have the most available IP addresses in every network. And in Class C, we have the least available IP addresses per network. Now, how can we count for the number of available IP addresses? There is a formula that I'm going to go ahead and write it here. So for the number of hosts, 2 to the power of host bits minus 2 gives us a total available of IP addresses that we can use for that network. And as we talked about in previous videos, why we do the minus 2? Because 2 IP addresses we cannot assign to the computers. One of the address known as network address and the other address known as broadcast address. These 2 addresses are reserved and we cannot assign to the computers on the network. That's why we need to do the minus 2, take out 2 addresses to get the total available IP addresses. So for example, now let's take a look at Class C. How many host bits do we have? If we want to find out how many available IP addresses we can have in every Class C network. Very good, zeros, that's the host bits. So it is 2 to the power of host bits. How many? 1, 2, 3, 4, 5, 6, 7, 8. 2 to the power of 8 minus 2. 2 to the power of 8, that's 256 minus 2, 254. So 254 available IP addresses we have in Class C network. Now let's compare this to Class A network. So I'm going to go ahead and erase. So in Class A, how many host bits do we have? We just need to count the number of zeros, which is 24. So 2 to the power of 24 minus 2, which is 16,777,216 minus 2 is 16,777,216. 277,214 available IP addresses per Class A network based on its default subnet mask. So in Class A, based on its default subnet mask, we can have, I'm going to write down here, the total of number of hosts available IP addresses for Class A. Okay, I'm going to go ahead and erase here. Let's erase all this. And now let's go over Class B. In Class B, we talked about, again, to find out the available number of hosts, 2 to the power of host bits. How many host bits do we have? In Class B default subnet mask, we have 16 zeros, right? And the zeros represents the host bits. Therefore, 2 to the power of 16 minus 2, which is 65,536. And minus 2 to get the total available IP addresses, which is 65,534. So in Class B, using default subnet mask, we will have 65,534 available IP addresses. So I'm going to go ahead and erase all this, and let's write down the number of hosts. And for Class C, you guys remember what was available number of hosts? 254, right? 2 to the power of host bits minus 2. So again, Class C, we had 8 bits for the host, right? 2 to the power of 8 minus 2, 256 minus 2, 254. So just remember this formula to get the available number of hosts. We have 2 to the power of host bits minus 2. And this applies to the CIDR notations as well when we do the subnetting, not using the default subnet mask. So for example, if we had also, let's say in Class B, let's say if this one and this one also it was turned on, therefore would be the available IP addresses we can use. But here in this example, we are just using the default subnet mask. And just remember, this is the formula to get the available number of hosts. And to get the number of subnets, we have this formula, 2 to the power of subnet bits. So in this example, this is a default subnet mask. We don't have the subnet bits. In the future, we will talk about regarding subnetting and what are the subnet bits and all that. So just a quick example, when we borrow from the host bits, let's say in Class C, we borrowed this bits and this bit to be also part of network bits. So we turned it on. In this case, we have 1, 2, 3, 4, 5, 6 zeros and 2 ones, right, on the last octet. So these two considered the subnet bits. So all the ones, network bits, these two subnet bits, and all the zeros, host bits. Therefore, in this example would be 2 to the power of 2, which is 4. It would give us 4 subnets. But again, we talked about this more in other videos. Please make sure to watch those videos. Just remember, this is the formula for the number of subnets, 2 to the power of subnet bits. And it gives us how many subnets we can have when we talk about subnetting. But in this example, this is a default subnet mask, and it's just one big network. And in that one big network, how many available IP addresses we have. So in Class A, we will have 16,777,214 available IP addresses in Class A. In Class B, 65,534 available IP addresses. And in every Class C network, we will have 254 available IP addresses. I hope this video was helpful. If you have any question, please leave it in the comment section. If you like the video, please hit the thumbs up. And if you want to see more tech videos like this, please make sure you subscribe to our channel. Thanks again and have a good day.